Hello everyone. This is lecture number 5 of engineering mechanics course. The content of this lecture would be the resultant of concurrent force system by method of resolution. That is, we are going to do numericals on concurrent force system. So same like we did in the previous lecture, similar kind of problems we are going to do in this lecture. Let us go for the first problem. Three forces of magnitude 40 kilonewton, 15 kilonewton, 20 kilonewton are acting at a point O as shown in figure. The angles made by 40 kilonewton, 50 kilonewton and 20 kilonewton forces with the x-axis are 60 degrees, 120 degrees and 240 degrees respectively. Determine the magnitude and direction of resultant force over there. Okay, so this is very simple problem compared to the earlier problem. Okay, so let us prepare a tabular data and then we can find out the answer for R. Okay, so my first column would be force and second column would be X component, and then third column would be Y component. Okay, so the first force is 40 kilonewton. Let us take as 40 kilonewton. What is the x component of that 40 kilonewton? 60 degrees making an angle with respect to x axis. That is for 40 cos 60. You'll get the answer as 20 kilonewton. Okay, so this 20 kilonewton is acting in first quadrant. That is 40 kilonewton is acting in first quadrant. X and Y component will be positive there. Okay, so Y component will be 40 sine 60 degree. You'll get the answer as 34.64 kilonewton there. This is regarding the first force. Coming to the second force, that is 15 kilonewton. The X component would be 15 cos 120. Okay, so 15 cos 120, so it will become minus over this. So let us consider a single quadrant here. Okay, so 15 kilonewton is acting in the second quadrant. It is making an angle of 30 degrees with respect to y. Okay, the total angle is 120 degree, so we'll subtract that 90 degree, that is first quadrant, and the remaining is what? 120 minus 90 is 13 degree. That is 15 kilonewton is making an angle of 30 degree with respect to the vertical axis there. So it will become 15 sine 30. The answer is 7.50 there. Okay, so it will be minus. Why? Because it is acting in negative, that is second quadrant. So my y component would be 15 cos 30 degree. So it will be my plus 12.99. Okay, so this is 12.99 kilo Newton here. Fine. So the next one would be 20 kilo Newton then. Okay, so my x component would be, so I'll subtract 180 degree of this 240. That means I'll get 60 degrees with respect to the horizontal. 20 into cos 60, you'll get the answer as minus 10 kilonewton. Why? Because that 10 20 is acting in third quadrant. X and Y component will be negative over there. Okay, so my Y component will be 20 sine 60 degree. You'll get the answer as 17.32 kilonewton. Now we have resolved all the forces into X component and Y components. We can easily find out the answer for summation Fx and then summation Fy. Okay, so summation Fx equal to 20 minus 7.5 minus 10. You'll get the answer as 2.50 kilonewton there. And summation Fy is equals to 34.64 plus 12.99 minus 17.32. You'll get the answer as 30.31 kilonewton there. Okay, so this is my summation Fx and summation Fy. So R is given by the formula square root of summation Fx square plus summation Fy square. So Fy square. So the answer is that is 2.5 square plus 30.31 square. Square root of answer would be 30.41 kilonewton. So this is my magnitude of the resultant force. Now I have to find out what is the direction of my resultant force. That is tan inverse of summation Fy, that is 30.31 divided by 2.5 kilonewton. Okay, so it will become 30.51 divided by 2.5. My angle is 85 degrees, 85.32 degrees. Okay, this is my resultant, magnitude of the resultant and the direction of result. This completes problem number. Second problem is three forces of magnitude 40, 20, 15 kilonewton and 10 kilonewton. Okay, just make a correction over there. It is not three forces, it is four forces of magnitude 40 kilonewton, 20 kilonewton, 15 kilonewton and 10 kilonewton are acting at point A as shown in figure. The angles made by all these forces with respect to the x-axis are 120 degrees, 90 degrees, 60 degrees and 30 degrees. Okay, as shown in figure. Determine the magnitude and direction of resultant force there. This is very simple. Force x component and then y component. Okay, so what is my first force? Here it is 40 kilonewton. Okay, so 40 kilonewton, x component of that 40 kilonewton. You can see there 40 kilonewton is acting at an angle of 120 degrees with respect to horizontal there. And then you can see there R4, that is 40 is acting in second quadrant. My x component will be negative and y component will be positive there. That is 40 cos 120, or else you can take it as sine 30. So it depends on your convenience what angle you are going to take over there. Okay, so for me, I'm getting the answer for x component as 20 kilonewton here. Y component, I'm getting it as 34.64 kilonewton. This is my y component. Okay, let us go for the second force here. That is 20 kilonewton there. So my x component will be equal to 0 there, and then y component will be equal to 20 kilonewton there. Okay, so my third force, that is 15 kilonewton. 15 kilonewton, the x component of that 15 kilonewton would be 15 cos 60. The answer is 7.5 kilonewton. So similarly, y component is 15 sine 60, you'll get the answer as 12.99 kilonewton. So this is my third force. So let us go for the fourth force, that is 10 kilonewton here. So the x component for that would be 10 cos 30. The answer is 8.66 kilonewton. So y component is 10 into sine 30 degrees. We'll get the answer as 5 kilonewton. So now the resolution of all the forces are over. Let us find summation of Fx and summation of Fy. Okay, so summation of Fx is minus 20 plus 7.5 plus 8.66. We are going to get the answer as minus 3.84. So coming to summation Fy, it is 34.64 plus 20 plus 12.99 plus 5 kilonewton. So the answer for this is 72.63 kilonewton. So let us go for the formula for R. R is given by square root of summation fx square plus fy square, that is minus 3.84 whole square plus 72.63 whole square. So the answer for this would be 72.73 kilonewton. This is the resultant. Coming to the magnitude, that is theta is equals to tan inverse of my 72.63 divided by 3.84. So you'll get the answer for theta as it is 6.97 degrees. So this is the magnitude and then direction of the resultant force. This completes problem number 2. Coming to the third problem. So here you can see there the block is resting on the inclined plane. Inclined plane is making an angle of 45 degrees with respect to the horizontal there. Okay. So 600 Newton force is making an angle of 45 degrees, 700 Newton force is making an angle of 30 degrees, and 800 is acting exactly along the vertical axis. Okay, we have three forces here. So let us find out the resolution of each forces. That is force x component and then y component. Okay, the first force is 600 Newton force. 600 Newton force is directed towards the third quadrant of the axis there. Okay, reference axis. That means x component and y component will be negative there. So the answer is 600 cos 45. You'll get it as minus 424.26 Newton. And similarly, for y component, it is minus 424.26 Newton. So coming to the second one, that is 700 Newton, it is directed towards the fourth quadrant. In fourth quadrant, x is positive and y is negative there. That is 700 into cos 30 degrees. You'll get the answer as 606.22 Newton, and y component as 700 sine 30 degree. You'll get it as minus 350 Newton over there. This is regarding the second force. Coming to the third force, that is 800 Newton, we have x component as 0 and y component as plus 800. Okay, so let us find out what is summation of fx and summation of fy. Summation of fx is equal to minus 424.26 plus 606.22. You'll get the answer as 181.96 Newton. So coming to summation fy is equals to minus 424.26 minus 350 plus 800. You'll get the answer as 25.74 newtons. So with the help of these two values, let us find out the answer for R here. So R is equals to square root of summation fx square. Summation fx square is 181.96 whole square plus 25.74 whole square. So you'll get the answer for resultant as 183.76 Newton. So this is the resultant of the given problem. This completes problem number 3. This is problem number 4. That is, a truck has to be pulled along a straight line or the straight road as shown in figure. Okay. First condition, if the force applied along rope A is 5 kilonewton at 30 degrees, what should be the force in rope B which is inclined at 20 degrees so that vehicle moves along the road. That means the resultant is towards the right side, that is towards the x-axis. If r is along the x-axis, what is the value of force B? Okay, so the next condition is if force of 4 kilonewton is applied in rope B, at what angle rope B should be inclined so that the vehicle is pulled along the road. Okay, so we have to find out, first thing is FB and the next one is alpha equal to 38 alpha. Okay, so the answer for this problem is given at the end of the slide. You can see there FB is equal to 7.31 kilonewton and alpha equal to 38.68 degrees. Okay, so let us find out the same problem. Okay, the solution for the same problem. That is, if 5 kilonewton force is acting along A, it is making an angle of 30 degrees. What should be the force in B if it is making an angle of 20 degrees? Case 1. Okay, so now here this is making an angle of 20 degrees. Okay, this is making an angle of 30 degrees. The value of A is the value of force in rope A is 5 kilonewton. Okay, so now the given condition is if R is equal to summation Fx. Okay, so this is the given case, that is the resultant, that is the vehicle should move along the in the sense the resultant should be along the x-axis. In this case, so let us find out the table here. Okay, so force and then x component and y component. Okay, the first force, that is 5 kilonewton. 5 kilonewton is acting in the first quadrant. So x component and y component will be positive, that is 5 cos 30 will be equal to 4.33 kilo Newton there. Okay, this is my x component. Let us go for the y component, that is 5 sine 30 degree. You'll get the answer as plus 2.5 kilo Newton there. Okay, so we'll go for the next force, that is force in B rope. Okay, so we don't know what is the value of P there. Let us take it as F. Okay, F cos, so it is acting in the fourth quadrant, that means X will be positive and Y will be negative there. That is F cos 20 degrees. Okay, so you'll get the answer as cos 20 is equals to 0.94, that is 0.94 F. Similarly, y component is minus F sine 20 degree. So sine 20 degree is what? Sine 20 degrees is equals to 0.34. So that is minus 0.34 into F. So we found out x component and then y component of both the forces here. So let us find out summation Fx here and then summation Fy here. So it will become 4.33 plus 0.94 F and then 2.5 minus 0.34 F. Okay, so here R equal to summation Fx and then summation Fy is equals to 0 there. So we'll go for summation Fy equal to 0. The value of F will be, that is 2.5 minus 0.34 is equals to, sorry, F is equals to 0. So the answer of F is, that is 2.5 divided by 0.34. So it is 7.35 Newton. Okay, so this is my force in B row if it wants to move in X direction then. Okay, so case 2. What should be the angle if it wants to move along the road here? Here we have found out. So let us discuss this case 2 in the next slide. In case 2, it is given as if the force is along the B is 4 kilonewton, what should be the angle of inclination there? Okay, so for that, so let us prepare a table like this. We did in the previous problem. That is force, X component, and then Y component. Okay, so the first force is 5 kilonewton, which is making an angle of 30 degrees with respect to the horizontal. So the answer for X component is 4.33 as it is acting in first quadrant. So both X component and Y component will be positive there. Next one is 5 sine 30. We'll get the answer as plus 2.5 Newton there. Okay, so this is my first thing. Next one is 4 kilonewton force is given over there. Okay, in the question. So my X component would be 4 cos theta, so it will be plus, and then this is minus 4 sine theta. Okay, so what is given in the question? The resultant is acting along X direction, and then summation Fy is equals to 0 here. Now what we'll do here is we'll apply the same rule as that of the previous one, that is 4.33 plus 4 cos theta, and then this one is 2.5 minus 4 sine theta there. Okay, so we'll apply summation Fy equal to 0 here, that is 2.5 minus 4.5 sine theta is equals to 0 over there. Fine. Sine theta, how much we are going to get? Let us see. Okay, 2.5 divided by 4.5. Shift answer. We are going to get the answer for theta as 33.75 degrees here. Okay, so this is how the problem is done. Suppose if the block is if the vehicle wants to move along the road, means a force of 4 kilonewton with an angle of 32 degrees 33.75 degrees with respect to the horizontal should be applied there. Okay, this completes the problem. Problem number 5. An eye bolt is pulled from ground by three forces as shown in figure. Determine the resultant force. Okay, so you can see there are three forces. The first one is 1000 Newton. It is acting exactly along the horizontal axis, and then there is one more force, 2000 Newton force, which is inclined and then lying in the first quadrant. The angle is not given, but the slope of the force is given. And similarly, 3000 Newton force is also acting in second quadrant then. So angle is not given, slope of the force is given there. Okay, so let us find out the resultant of the given problem. Okay, before proceeding, let us find out the angle theta here. Okay, let me take this as theta 1 and let me take this one as theta 2. Okay, so theta 1 is given by the formula tan inverse of 3 by 4. Okay, so 3 by 4 tan inverse, you'll get the answer as 36.87 degrees. Okay, so let me go for theta 2. Theta 2, again it is taken as tan inverse of 4 by 3. You'll get the answer for theta 2 as 53.13 degrees over there. Okay, this is my theta 1 and theta 2, and then 1000 Newton force is acting exactly along the horizontal axis. The angle is 0 there. So let us prepare a table here. Okay, so this is my force, this is my x component, and then this is my y component. Okay, so we'll start with force 1000 Newton. So 1000 Newton x component is plus 1000 Newton, and then y component is 0 over there. So let us go for second force, that is 2000 Newton there. So the x component would be, that is 2000 cos 36.87. You will get the answer as plus 1600, and then it lies in the first quadrant. Both x and y component will be positive there. So the y component would be 2000 sine 36.87. You'll get the answer as plus 1200 Newton force. Okay, so let me go for the third force, that is 3000 Newton force. X component would be 3000 cos 53.13. It lies in the second quadrant, that means x component will be negative, that is minus 1800 Newton force. Y component is positive, that is 3000 sine 53.13 degree. You will get the answer as plus 2400 Newton force here. So let us add all together and find out the answer for summation fx and then summation fy. Summation fx is equals to 800 Newton, and then summation Fy is equals to 2600. Okay, so this is 3600 Newton force over there. Okay, so let us find out the answer for R, that is square root of summation Fx square and then summation Fy square, that is 800 square plus 3600 square. You'll get the answer as 3687.82 Newton. So this is how the resultant of the given force system can be found out. This completes problem number 5. Problem number 6. Force is 7 kilonewton, 10 kilonewton, again 10 kilonewton and 3 kilonewton are acting at one of the angular point of regular pentagon towards the other 4 points taken in order. Find the resultant of the force system. You can see there is a pentagon diagram over there. At point O, there are 4 forces which are acting towards the other 4 points of the pentagon there. Okay, so let us take one by one. OA, will take it as first force, that is 7 kilonewton, which is making an angle of 0 degrees with respect to the horizontal. And then 10 kilonewton is making an angle of 10 with respect to the horizontal. And then 10 kilonewton, the third force 10 kilonewton is making an angle of 2 theta with respect to the horizontal. And the last force, that is 3 kilonewton, is making an angle of 3 theta with respect to the horizontal. So what we have to do? We have to find out the resultant of the force system. The hint given to solve this problem is sum of interior angles of a polygon is equal to 180 into n minus 2. What is n? It is the number of sides. Okay, so in this case, the number of sides are 5. So 180 into 5 minus 3, you will get the answer as 540 degrees here. Okay, the sum of all the sides as 540 degrees. Now I want to see what is the angle made by this side here. Okay, so sum of all angles is 540 degrees. I want to see what is the angle made at point O. So it will be 540 divided by 5. It will become 108 degrees total. So 3 theta is equals to, so let me write 3 theta is equals to 108. So my theta would be 36 degrees. Okay. Now we'll find out the components of each forces then. Okay. So forces x component and then y component. Okay, we'll start from the first one, that is 7 kilonewton there. So x component is 7 kilonewton and y component is 0 there. It is acting in first quadrant. Let us go for the second force, that is 10 kilonewton. So 10 kilonewton, it is acting an angle of 36 degrees with respect to the horizontal there. 10 cos 36, you'll get the answer as 8.09 kilonewton there. Similarly, y component is 10 sine 36 degrees. You'll get the answer as plus 5.88 there. Okay, so this is the second force, 10 kilonewton. The third force, that is 10 kilonewton, it is acting at an angle of 36 into 2. That is at an angle of 72 degrees with respect to the horizontal there. Okay, cos 72 degrees into 10, you'll get answer for x component of that force, that is 3.09 kilonewton. This is also acting in first quadrant. That's why both x and y component will be positive there. Similarly, y component is 10 into sine 72. We'll get the answer as 9.51 kilonewton here. Okay, so we'll go for the last force, that is 3 kilonewton. So as it is falling in second quadrant, how is it is 108 degrees. 108 degrees is in, the force is in second quadrant. That means x component will be negative and y component will be positive then. That is 3 into cos, you'll get the answer as 0.93. That is minus 0.93 kilonewton there. And then y component as 2.85 kilonewton here. So let us find out summation of all these forces. Summation Fx equal to 7 plus 8.09 Newton plus 3.09 Newton plus, sorry, minus 0.93 kilonewton. You'll get the answer as 17.25 kilonewton here. Okay, so let us go for the y component, that is summation fx there. 5.88 plus 9.51 plus 2.85, you'll get the answer as 18 point, summation fy is equals to 18.24. Let us find out the answer for r here. R is equal to square root of 17.25 square plus 18.24 square is equals to, let us find, it is 25.10 kilonewton. This is the resultant of the given system of forces. This is how we have to find out the answer for the given problem. Okay, so this completes problem number 6. Problem number 7. Let me read the question. The top end of the vertical rope is connected by two cables having tensions T1 equal to 500 Newton and T2 equal to 1500 Newton. Okay, as shown in figure. The third cable AB is used as guy wire. Determine the tension in cable AB if the resultant of three concurrent forces acting at A is vertical. also find out the result. Okay, let me take this one as T2. This is not displayed over here. This is T2 equal to 1500. Okay, so we have to find out the force in cable AB there. Okay, so let me take this one as T3 there. Okay, so this is T3 and then I'll take this angle as theta. Okay, so let me find out the resolution of the forces here. Forces, x component and then y component. We'll go from T1 then. Okay, T1 force is here and then x component of the T1 force is 500 cos 20 degrees. You'll get the answer as plus 469.85 Newton over there. Okay, similarly for y component, it is acting in fourth quadrant. X is positive, y is negative. 500 sine 20 degrees. You'll get the answer as minus 171.01 Newton. So coming to T2, we'll find out the x component for that. 1500 into cos 30 degrees, it will become minus 1299.04. X is acting in third quadrant, x is negative, y is also negative there. Okay, similarly y component is minus 750 there. It is Newton. So let us go for the third one, that is T3. So T3, I'll take it as F. Okay, so it is F cos theta and then minus F sine theta. X is positive and Y is negative. So let us add all these together. So 469.85 minus 1299.04, we'll get the answer as F cos theta plus minus 829.19 Newton. So similarly, summation Fy, we are going to get the answer as minus F sine theta minus, we'll get the answer as minus 171.01 minus 750. It is minus 921.01. Okay, so what is the condition given in the question is if the resultant of the three concurrent forces acting at point A is vertical, that means R is equals to Fy. Okay, in that case summation Fx is equals to 0 then. Okay, so let us go for this second condition, that is summation Fy is equals to 0 over there. Okay, so that is F cos theta minus 829.19 is equals to 0 over there. Now F cos theta is equals to 829.19 Newton over here. Okay, now we'll go for R equal to summation Fy. Okay, so R is equals to R cos theta, R sin theta. R sin theta is equals to minus F sin theta minus 921.01 Newton. Okay, so this is my equation number 2. This is my equation number 1. This is my equation number 2. So from equation number 1, we can find out the angle theta there. Okay, so you can see here, this is the angle made by the force T3 here. Okay, so let us find out this angle theta 1. Okay, so theta 1, I'll just draw a line like this. This will become OAB. This will become a triangle over there. We have to find out the angle theta 1. So tan theta 1 is equals to opposite upon adjacent. It is 19 by 12. You'll get the answer for theta 1 as 36.87. If theta 1 is equals to 36.87, what will be the answer for theta? That is 90 minus answer. You'll get the answer for theta as 53.13. Substitute this 53.13 in equation number 1. You'll get the answer for F. Okay, so F is equals to 829.19 divided by cos 53.13. So let us find out the answer for this. That is cos 53.13. Okay, so 829.19 divided by answer. You'll get the answer for F as 1381.98 Newton here. Okay, so this is my force in the cable AB there. Okay, so let us find out the answer for the resultant from equation number 2 there. Okay, or else we can directly enter the values here. That is R is equal to F, it is already known, minus 1381.98. What is this? Sin theta, sin 53.13 minus 921.01. So you will get the answer as minus 1381.98 sine 53.13 minus 921.01. So the answer is 2000 minus 2026.59 Newton. Okay, so the value for R is 2000 minus 2026.59 Newton. This is how the resultant of the given system can be found out. First thing is we found out the force in the cable, that is tension in cable AB, that is T3 then. T3 is equal to F. We have taken it as F there. So the value of F, we got it as 1381.98 Newton. Next thing is we found out the answer for R there. So R is equals to minus 2026.5. Let's go for the eighth problem. Determine the magnitude and direction of the forces F1 and F2 as shown in figure. Well, the resultant of the given force system is found out to be 800 Newton along the positive x-axis. Okay, there are totally four forces acting on the problem as we can see on the screen, that is F1, F2, F3 and F4. The values of F3 and F4 are given, that is F3 is 290 Newton and F4 is 370 degree. The value of F1 and F2 are unknown. And then one more condition is given here is the resultant of the given force system is found to be 800 and then it is acting along the positive x axis. Okay, that means R is equals to summation fx and summation fy is equals to 0. Okay, so let us find out the x component, y component of these forces. Okay, forces and x component and y component. Okay, so F1. So what is the angle made by this F1 is 90 degrees with respect to horizontal. So it will become 0 and then y component will be 90 degrees, that is force F1 itself. Okay, so let us go for F2. So F2 is equals to F2 and then y component will be 0 there. So let us go for the force F3, that is 290 Newton there. So x component of that would be 290 degrees into cos 36. You'll get the answer for that is minus 234.61 Newton there. Similarly, y component is 290 sine 36 degrees. You'll get the answer as plus 170.46 Newton. Okay, so we'll go for the last force, that is 370 Newton there. Okay, so 370 Newton. X component of that would be minus and y component also minus. 370 degrees into cos 70 will get the answer as minus 126.55 Newton. Okay, and then y component is 370 sine 70. We'll get it as minus 347.69. So we find out summation of these two things, that is F2 minus 234.61 minus 126.55. Okay, you'll get it as F2 minus 361.16. So similarly, summation Fy is equals to F1 minus 177.23 Newton. Okay, so this is my summation Fx and summation Fy over there. Okay, so let us go for the given condition here. Summation Fy is equals to 0. So we'll apply this condition here. Okay, so F1 is equals to 177.23. So when you apply that condition, that is summation Fy equal to 0, you are going to get the answer for F1 as 177.23 kilo Newton. So this is my first force, F1. So let us go for the second force, that is R is equal to summation Fx there. So we'll find out F2 value there. So how we find out is, first thing is we'll go for R equation, that is R is equals to 800 equal to square root of R equal to summation Fx. We are using this equation. R is 800 square root of Fx, summation Fx, that is F2 minus 361.16 whole square. So I'll remove the square root. Okay, how I remove is 800 square. So I'll get it as 66 lakhs 40,000. Okay, so what I'll do here is, this implies 6 lakhs 40,000 is equals to F2 square A square plus B square, that is 361.16 whole square. We get it as 130,436.55 minus 2 F1 F2, that is 2 into 1 2 into 361.16, that is minus 722.32 F2. Okay, so once we solve this equation, we are going to get the answer for F2 as 1161.19 Newton. Okay, so with the help of calculator, you can use this. You can solve this equation. The degree of the equation is 2. You can get the answer for F2 as 1161.19 Newton. So this is how F1 and F2 are found out. Here, while reading the question, you have to be very careful. The hint for each and every solution is given in the question itself. Okay, so in the given question, what is given here is determine the magnitude and direction of force F1 and F2. Okay, so in which the resultant of the given force system is found to be 800. R is given as 800, but where it is acting? It is acting exactly along the x-axis. If r is acting along the x-axis, r is equal to summation fx and summation fy is equals to 0 over there. These conditions we discussed earlier. Okay, you have to remember all these things. If r is acting along the x-axis, r is equal to fx and summation fy equal to 0. If r is acting along y-axis, r is equal to summation fy and summation fx equal to 0 over there. And then if R is acting exactly at an angle of 45 degrees with respect to the horizontal, then summation fx equal to summation fi. Okay, so these three conditions you have to remember whenever you are solving the problem. So here in this question, f1 and f2 are unknown here. So F1 is acting exactly along the vertical axis and F2 is acting exactly along the horizontal axis. So the angle made by F1 with respect to the horizontal is 90 degrees and the angle made by the force F2 with respect to horizontal is equal to 0 degrees. Okay, so we have to prepare the table like this. That is, the first column would be forces and the second column would be x component and the third column would be y component. Okay, so first we have to find out summation fx value and then summation fy value. We have two conditions, that is r equal to summation fx and summation fy equal to 0. So we have to apply these two equations condition and get the answer for f1 and f2. By applying summation fy equal to 0, we got the answer for f1. F1 is equals to 177.23 Newton. Then we use the equation, that is R is equals to summation Fx. So R value is 800 Newton. So we use this equation, that is R equal to Fx, in order to get the value of F2 there. So this completes problem number 8.